What's up guys, welcome back to my YouTube channel. My name is Pedro and today I'll be bringing us a tutorial of how to build an interactive dashboard application. So this application will be built with Python in a framework called Dash. This application will visually represent data of the United States and the data will be represented into counties, and it's going to be an interactive application, so the user will be able to select individual counties of the United States and display individual data as well. So for that, we're going to be using COVID-19 data and as well as heart disease data. And we're going to separate both diseases by its year. So for COVID-19, we're going to do like a live update. So it's going to be updating daily. And for the heart disease, since the CDC last update was in 2018, we're gonna display the heart disease data from the year 2018. And the inspiration for this tutorial was because I built this with a few other data scientists as a project for Lambda School. And this project led us to be part of a competition for Lambda called Shark Tank. So on this competition, we were able to showcase a project that way we could be found by potential employers, and that's why I also got inspired to make this tutorial, because that led us to be part of that competition. And I'll be putting the presentation in this video as well, but if you want to skip the presentation, you can feel free to do so. I'll be putting the minute where you can be skipping the presentation and just go straight to the tutorial. If you want to just go straight to the tutorial, just feel free to do so. Without any further ado, let's just jump right into it.
I'll be hosting tonight's Shark Tank. I want to thank you everybody that has joined and all the teams. The cohort worked really hard for the last 16 weeks. So I really appreciate the Sharks coming on and join us. And we'll go ahead and just kind of do a brief introduction of the Sharks. We'll start with you, Cecilia.
Sure. Hi, I'm Cecilia Zaniti, and I'm the general counsel of Lambda School. Before I joined Lambda, I was an in-house lawyer at Amazon, where I had the opportunity to work on Alexa and the app. And early in my career, I worked at Yahoo, which dates me a little bit, but I spent some time in product management. My husband is a product manager. I kind of play an engineer on TV sort of thing. So I really enjoy connecting with you all. And I think I've used just about every consumer app out there. The only ones I haven't used is dog walking apps because I don't have a dog, but cleaning, car washing, Instacart, DoorDash, every possible consumer app I have used it. So looking forward to see what you guys come up with.
All right, Chris.
Hey guys, my name is Christopher Atoki. I am an associate web instructor here at Lambda School. And before Lambda School, you know, I worked at a few different companies like Comcast, IBM for a little bit, a small startup called Lunchbox. And, you know, I'm a front-end engineer by trade, so that's what I like the most. You know, back-end guys, you guys are too smart for me, so I'll stick with moving my pixels. And in fact, before then, I was actually one of the Lambda School OGs. I went to Lambda School about 3 years ago. So I'm just really excited to see, you know, this Shark Tank, process, and just see what you guys have built and worked so hard on for the last you know, few months now. So yeah.
Awesome. Brent?
Howdy. So I am Brent Anderson, and I am a senior software engineer here at Lambda School. I've been here for about a year and a half, a little more than a year and a half. And I, previous to that, I was also at a startup that you've never heard of, because we were trying to make DVDs and Blu-rays more popular again than they are right now. And you can imagine how well that went. We were doing some like video mashup AI stuff on the side with it, but the core product just was kind of doomed from the start. But hey, it was fun. And then before that, I built and ran a tech team at a consumer product company called Blender Bottle. They're the ones that have like the wire whisk inside of the shaker cup if you do protein shakes and, you know, nutrition and stuff like that. So got to build that from the ground up, which was a lot of fun. And in a past life, I ran an iOS app development company, like way back when the App Store first launched, so back in 2008. And that was a wild ride because it was new and kind of fun. So that was a long time ago, though.
Thank you, Brent. Thank you, Sharks. So our lineup's going to be Find Your City, Fault Line, Workout Tracker, and NutriVerb. And Kelly, we'll let your team kick off.
All right. Oops. Oh, come on. What is going on? There we go. Okay. Imagine a world where you can choose the location to where you live based on your values. Find Your City is an app that helps a user determine the city they like to move to. It gives a city and its local government a kind of credit score based on multiple criteria. So our team is composed of 3 parts. Our team lead, Kelly, our data scientists, Arturo, Ashley, James, and Pedro, our web developers, Anna, Ben, Brian, Connery, and Sean. And we each had our own goals. Our data science team had the goal to collect and implement heart disease and COVID data to demonstrate via visualizations. And our web team had the goal to upload and delete functionality for photo on profile page and UI changes with accessibility. I'm going to hand it over to Ashley.
Thank you, Arturo. Let's discuss the problems that we addressed. Most websites like Find Your City don't include important information about public health data. In order to have this data accessible to our users, the data science team focused on solving that issue by incorporating data visualizations for 2 major health concerns, heart disease and COVID-19. The focus of the web development team for Find Your City was to make the existing website easier to use and more appealing to the eye, while improving accessibility for all users that use special tools to navigate, like screen readers, contrast adjustment for color vision impairment, and incorporation of alt tags for hearing impairment. And with that, I'll pass it on to Pedro.
Thank you, Ashley. The RC goal for the data science team was to visually represent data of the #1 cause of death in the United States, which is heart disease. We obtained the data through the CDC website. Their last update was from 2018, so we collected the data from that year. We collected the data as CSV files. We had to merge the data since it was collected as counties to all already existing data that we collected for cities. So for that, we had to use an external library called GeoNames Cache. And to get the geometric shapes in order to plug it into our map, we had to use another external library called GeoPandas. So the web team designated an area that links the application that the data science team created to visually display the heart disease data. So we created this Dash application, which is Dash is a framework for Python. It's a fully interactive application that lets the user have a good experience obtaining data from the United States. As you guys can see, the data is represented by county. And here below, we have an overview of the data from the United States. But since the map is fully interactive, the user is able to click and drag into the map and select individual counties. So the counties each have their value. The data is collected. The user is able to click and drag in any part of the United States. Data onto the web.
Thanks, Pedro. Okay, so I'm going to go over the general flow of our app. When you first go to Find Your City, the first thing that we want you to do is search for a city. I'm going to search for Saratoga Springs, Utah. And that'll bring information about your potential city that you may want to move to or want to know more about. We've sectioned the data by population, climate, economy, industry, and cost of living, as well as the health data that Pedro was going over earlier. So let's say that I really like this city and I want to, save it for later. I'll click on that star. It'll ask me to log in or create a profile. and that'll take you to your profile page. From here, you can see the favorite cities that you have favorited. You can take a survey, and what the survey does is it gives you a list of potential cities that would fit criteria that you put down. So I'm going to hurry and take this survey. And it'll give me a list of cities like Arvada, Colorado. That sounds like fun to me. So once I've favorited a city, I can go back to our profile and it'll show up for you right there. For the first part of our application, we worked pretty hard on this profile page. One of the big challenges was uploading an profile image. We used Cloudinary library for this. I'll just demonstrate how that works. And voila, we can update our profile, pictures, information about our profile, retake the survey, and keep finding favorite cities. And with that, I will pass it back over to the data science team.
Thank you, Ben. The target goal for RC2 for the data science team was to visually represent COVID-19 data. And for that, using the same architecture as the release canvas one, we incorporated data from COVID-19. Since the data that was released to the CDC was compromised through political interests, we decided to use a different repository where we are collecting data that gets updated daily. So we're using a dynamic URL in order to obtain that data. In order to access the visualization, the user just have to pretty much just click to this URL, which is going to take you to the already existing application, which is this one. In order to access the COVID-19 data, the user just pretty much have to just select the year 2020, since this is the current year we're on. Then the data will get loaded into the map. The data is also collected as counties, and we decided to differentiate both diseases by color. And it has the same functionality as the heart disease data. So the user is able to just click and drag into the map and select the counties that they decided to use visualize the data. We have a drop-down menu here below that lets you interchange between heart disease and COVID-19 data. So in order to display the COVID-19 data, the user just pretty much have to do the same thing, just click and drag into the map and just select the counties that they desire to display the data out. As we can see here, the county with most cases is Los Angeles. But obviously, the user can display data from the rest of the counties. The target goal for the data science team was to visually represent 50% of the data of the United States, but for heart disease, we were successfully able to do so, and for the COVID-19, we were close to 100%. And like I said before, it's full interactive application. The user is able to interchange between diseases and visually represent data. And for that, now I'll pass it on to the web team.
All right, so the main goal for the release canvas 2 was to decrease the number of accessibility errors and improve the UI. Previously, the app had a very unattractive UI, and it has some routing errors and also some state management issues. Also, the application was not accessible to users who required readers or screen readers or other accessibility devices. For example, the color schema caused contrast errors and limited our users with impaired vision or color blindness to smoothly navigate the app. Or HTML structure was missing area labels or proper HTML tags. To improve the accessibility, we used a tool called Weave, which takes the URL of the page, analyzes its structure, and returns a list of errors and warnings with improving solutions. So I'm going to demonstrate that. We managed to get rid of all the errors that we had. As you can see, there are no accessibility errors, and we managed to do that for all the pages in our application. I'm gonna also demonstrate the city view. So previously, this page was very unappealing to read. and we completely transformed this page. It used to be like just paragraph with the data information. As you can see now, it has this very readable cards. In addition to that, we implemented this bar graph, which displays the most common industries in that specific cities. It was built using recharts. And also, as you can see, the health data, which leads to the interactive map. We would love to have this for future releases. We would have to have the map visualization incorporated on the same screen. And as the rest of the pages, this page is accessible and has no errors. And I'm going to pass it to Connery to talk more about the profile page. Thank you.
Well, hello, and thank you, Anna, for passing that on. So I worked more on the profile page side, and once you log in, it brings you straight to the profile page. From there, you can add your name. Be anything, of course. Date of birth, address. That'll take you to the edit form page. Underneath the picture, you'll have your info that was placed in the add profile form listed underneath the profile picture. You can edit from there. And the edit will take place within the same fields. And you can also delete your information by hitting this button, which will bring you back to the add profile form. Of course, underneath the add profile form, you have your favorite cities, and you can search for a city also. And that's it for Find a City. I hope you enjoy it.
All right, team, thank you so much for your presentation. We'll get some feedback, any questions from the sharks.
Sure, I'll dive in. Yeah, so really impressed with the overall concept. Funny enough, one of my friends from college is actually creating this app as her startup. It's called Suburbit. And she had this idea that people were moving out of New York City and needed to find a town match. So I love that you guys have brought that to life. I thought that the incorporating health data was a really interesting concept. So good job, data team. In general, we've all seen with COVID that county level data is really hard to parse and really, reported at different times and things like that. Curious your thinking with the update frequency.
Yes, the data gets updated daily. As I mentioned, we have a dynamic URL that runs a script that allows the application to get daily updates. So every single day we get updates. Forgot to mention that, but yes, let me just share my screen real quick.
Yeah, that's helpful. Mm-hmm. I think on the front end, one thing that I noticed was as a user, I was craving a little bit of...
Sorry.
Oh, go ahead.
No, it's because I couldn't share my screen. Go ahead, I'm sorry.
I was craving a little bit of context on some of the things. So for example, if you check out Zillow, they have a walk score and it'll be like the walk score is like 19 or whatever. And it'll say, you have to walk everywhere or you have to take a car everywhere. Here, for some of the data on the town page, like density, it would be like 1,500 or whatever, it gave a number. And as a user, I didn't know what that meant. So maybe, I guess it's Anna. Can you tell me a little bit about, like, you mentioned what you would do as a next step for that page, but tell me a little bit more about your thinking on the UX of that page.
Yeah, we just didn't have enough time, but we were thinking about adding some, like a little model with, when you click on it, it gives you more information about what this number means. Like, for example, for the air quality, what does that mean? is it a good number or not, or like in general
Yeah.
explaining the, like, or for example, to be in the average in the United States or in the average of that state, or, you know, giving more context so the user understands better what does that mean.
That's awesome. This is great. I really like what you guys have done with this.
Thank you so much.
And
Like I
also
was
the
mentioning,
commute time. I love that you put in the commute time as well. Commutes are shown to long commutes are shown to shorten your life. So so good job on that, guys.
Thank you.
yeah, thank you so much. Just to quickly show you, we have named it as daily live update because we're getting live updates every single day. And just to show you the dynamic URL, we have it here. We're obtaining the data through this repository, and we have this script here, this function that it gives us the accessibility to get daily updates.
Yeah, that's really good. I mean, we've seen with COVID, you know, Johns Hopkins was kind of the first to come up with that great visualization of that data, and then they've become the default. That's everybody knows them now. Even my mom is like, "Did you check Johns Hopkins?" I'm like, "What? Like, how is that even possible?" So it definitely, you guys were creative in that way. I also thought whoever demoed the accessibility, just in general for demos, anytime you can show something, passing a test during your demo, that's really effective. I thought that was really good. I did want a little bit more pictures overall, but that's very front end feedback. And I'll pass it over to my other shark, or maybe I don't know if I took too much time, Derek.
No, you're fine. Chris or Brent?
Hey, I'll go. This is Chris. First thing, just to kind of bounce off of what Cecilia was saying, accessibility, I love it. One thing that's near and dear to my heart is accessibility, because I believe the web should be for everybody. So you guys spending a lot of time on that really makes me happy. So that's really good. One of the things, you know, about the front end, and as a front end engineer, I like seeing that things are right where you need to be, right where they need to be. You know, nothing's like out of place. I can, you know, everything that you need is right in front of you pretty much. So it's very easy to navigate. One of the things, can somebody display the form that there was? I think you could send, click some radio buttons and it might give you a suggestion, I think it was.
You're speaking of the survey form?
Yes.
Survey. Ben, do you have that up?
I can show that really quickly.
Thanks, Anna.
Yeah, no problem. Yep. We
So
have a little.
yeah, for the population of your dream city, it seems you guys have no preference below 10K, 10K to 30K, 31K to 99K, and then above 1 million. So the fourth and the fifth one, what made the large jump? Because that is a super small city to a very large city, but nothing in between.
Yeah, unfortunately, we did not work on the questions for the survey that was made by the previous team. We didn't get to work on that. It needs improvement, and we were thinking for the future releases to add more questions, so the recommendation would be more accurate. So the questions definitely needs a little bit work.
Yeah.
There are also some bugs in the recommended because of how the questions are, so it needs some work.
Gotcha, but yeah, it looks good. Just wondering. That was just one thing I saw. You know, just
Yeah,
that was really good.
we wish we had more time for this, but thank you. Thank you for
Sure.
that.
You know, just a few other things, just tying it up. One thing I love to see is consistent, you know, a color scheme and everything. You know, the style was very consistent throughout. I mean, you know, it was minimalistic, but that's the kind of style that I love anyway. So I like to see that. You know, the only thing that I saw that was different was, I think the profile page, whenever you're signing up, that had a red bar that, you know, swam through it, which is a nice animation itself. But I think, you know, maybe if that was blue, that would have tied it in with the rest of like the buttons and everything. And then, you know, the last thing that I had that was great, there's no lag time. You know, you don't have any loading bars that's waiting through, having to like have all this data load or anything like that. So you guys must have did really good on the data with the, you know, the front end part of it. Like I said, that's really near and dear to my heart. But overall, you know, you guys did a really good job on this. You should be really proud of yourself, and everything is tied together really good. It's not bloated or anything, but yeah, I just want to say great job overall.
Thank you.
Thank you.
So I did have a quick question about your backend and what your who is maybe responsible for putting it together, and just what, if you could just describe in detail, how did you, like, where are you storing your data? How did you model that? What does the backend look like? I know that there was some Python involved, but I'd love to hear a little bit more detail about some of those behind the scenes pieces.
Yeah, so pretty much everybody participated on the back end this time around. So the survey data and the city data was data and science's forte for sure. What we did for the web team is focused mainly around the profile page and using Cloudinary and saving all that data to a web server and calling it good that way.
So like storing it in memory on the web server, or is there a database that's behind it, or how are we persisting the data once it gets to the web server?
So we used Heroku, and we used Node.js on the back end to send that information to use Heroku to save that data onto Heroku, basically.
Yeah, we're using Postgres SQL as a database. We used Node.js, Next, Express, and it's deployed on Heroku as Ben mentioned.
Nice, cool.
Thank you.
Hey guys, so very quick before I jump into a tutorial, I just wanted to quickly show you guys how the website looks for the project that we did for Lambda School. So this is how the website looks, and the project is called Find Your City. So I just wanted to quickly show you guys how it looks and how you can find the interactive dashboard that we created for this project. So you just click this link and it will take you to the Dash application. I didn't actually click it because it takes a while to load since we're using the free service. But yeah, this is how it looks. It's interactive. You're able to change with this slider between years, between 2018 and 2020, and it will display different colors. And as well, when you drag into the map, it will select individual counties, and also you can drag and zoom in here and just look into the individual counties. So the data is split into counties, and that's how we're gonna work it. So that's how the CDC releases their like health concerning diseases and all that. It's just split into counties because it's easier to track. And you're able to change between diseases, between the heart disease and the COVID-19. So it's pretty simple, but it also looks pretty appealing. And I also wanted to mention that I designed this logo, and I'm planning to make future graphic design tutorials. So if you want to see tutorials from me, just subscribe. I'm gonna show some of my techniques which are different from other designers. And lastly, because it's worth mentioning, one of the sharks for our presentation was King Atoki. He's very important for Lambda because he was one of the first OG graduates, and his story is very inspiring because he was actually homeless since he was 18. He worked over 12 hours a day and still was a student. So his story is very inspiring. If you wanna see them, I'm gonna put a link in the description so you can see his story. How he overcame this struggle, and I identify myself with him because I've been working 12-hour shifts as well. Well, I used to work 12-hour shifts and also being a student, so I do know the struggle. And if any of you guys are doing this, I just want to say that just don't quit and keep hustling. And if you keep working hard, you actually will see improvements in your life, and one day you'll change your life. Alright guys, so let's get this tutorial started. I'm gonna be using PyCharm, but if you wanna use another IDE, it's up to you. Okay, so I'm gonna go ahead and create a new project. I'm gonna save it into the desktop and I'm gonna name it dashboard. Okay, dashboard. We're gonna use a virtual environment with Python 3.7. I'm just opening Safari so I can just project whatever I'm coding. Okay, now that we created a project, we're gonna create a new Python file. I'm gonna call it app. Alright. Okay, so we're gonna install a few dependencies. So we're gonna do a pip install. We're gonna do pandas like this, so we can install the pandas library. We're gonna install dash. Okay guys, so I imported these libraries and I install whichever library it asked me to install. I pretty much repeated the same process, but since I don't want to take you guys time, I'll just skip those installs. We're gonna go ahead and initialize the application. For that, we're gonna call app equals dash that dash. Then we're gonna initialize like the name, and then we're gonna call this meta text, which is gonna be the name, viewport of the content. And we wanna make it interactive. For that, we're gonna specify that the width of the device is gonna be the width of the screen. So whenever you drag, it's gonna shrink or expand as the screen size shrinks or expands. Then we call the server, which is gonna be the app.server. The server is what allows you to display the data on the browser. So that's gonna be the server. Gonna use some data that I have set up for you guys, and it's pretty much the same that I use for my application. So we have to do some steps to be able to import that data, and for that we're gonna go to Colab from Google, and it's pretty much like a Jupyter notebook, but it's online. So we're gonna go ahead and create this file. I'm gonna call it data2map. And we're gonna do some imports as well. We're gonna do some we're gonna install some libraries and import a few files that I'm selecting, but I'm gonna just leave whichever files you guys need, so you guys are not gonna import the same files like me, but you're gonna import whatever you need. So I'm gonna just leave it into the description. You guys can go ahead and use those files. So after we install these dependencies, we're gonna go ahead and do our imports. So just go ahead and copy what I'm writing on the screen. we're gonna start by using the hard disease data. So we have to define the data frame. So for that, I just call it hard disease, and then I just did the pandas import CSV file. So just go ahead and copy me, and then just to display the data frame, I just have to call the hard disease variable. And you can also do hard disease.head, so you can just display the first 5 rows, but I'm displaying all the rows and columns, so for that I just called hard disease. Okay, so I'm defining hard disease FIPS, which is pretty much the zip codes. So I'm applying a Lambda function to make sure that the zip codes have 5 characters. For that, I'm using Lambda string x cfill 5, so I can just define to be 5 characters, and that way I can work better with the zip codes of the counties. Next, we're gonna set up the county shapes, and for that we're gonna go to my Github repository, which is called Mapbox Counties JSON. In there you can find use counties file.json, which is gonna contain the counties geometric shapes. So you have to go to the raw file and just copy the URL. That way you can use that for a data frame. To be able to use the data, you have to use the GeoPandas library. For that, you have to call the GDP abbreviation read file, and then just paste the URL. That way you can be able to use the GeoJSON file, and then you can use it as a data frame. Next, I'm defining a function that is going to be called match range, and then I'm going to define bins, which is going to be the ranges that display like the color in the map. Like as the value increases, the color should change. So that's pretty much the bins. And we're gonna stick to just integer values. That way it's easier. We're gonna create a copy of our already existent data frame for hard disease. For that, we have to define the hard disease.copy, and then we're gonna call into a new variable called hard disease2, and then we can call hard disease.head, so we can display that it's the same data frame, but it's a copy. That way, we are not gonna affect the already existent data frame, which is called hard disease. Then I'm gonna use the crew rate as just value bins, and for that I'm renaming the column crew rate as bins. Then I'm displaying the data frame. That way it shows that the crew rate column has been renamed as bins. That way we can identify what we're gonna use as bins. And like I said, we're gonna be working with the bins as integers, and for that we're gonna convert the bins from the data frame of the hard disease to integers, because right now they're as doubles, so we're gonna have to convert them as integers. For that, we're gonna define as type integer. Then we're gonna create a column called match range, which is going to match the range of the bins to the value of the counties. For that, we're gonna do hard disease 2 and then define the bins that apply match range. That way we can apply the function into the column. As you guys can see on the match column, we are matching the values of the bins from the function to the values of the counties. Now what I'll be doing is save this data frame into a CSV file, and I'm setting up the index as false because we don't want to have an extra column at the beginning. The next step will be to merge the hard disease data frame into the county shape data frame. For that, we're gonna be calling the DFG data frame. So I'll be adding the extra word county under the name column. That way you can have the county's name and the word county next to it, because that's the way the hard disease data frame has named their counties, having that extra word at the end, which is county. The next step will be to merge the hard disease data frame into the counties data frame, which is the DFG data frame. Now on the hard disease data frame, I have the counties column name as unnamed 0, which is not something that we wanna be using. So I'll be renaming that column into name. That way we can match the counties shape data frame and we can merge them. Now we're gonna create a new data frame called merge, which is going to be merging the county shape data frame, which is the DFG, into the hard disease data frame. We're gonna merge it on the name column, which is the counties. That's why we rename the counties column in the DFG data frame and change the column name of hard disease into name. And for that, we're gonna be using a function called dfg.merge. Okay, so now that it's merged, I'm just going to see the type of this data frame, which is a GeoPandas geo data frame. I'm gonna also display the first 5 rows of this merge data frame, so we can display and see our changes and additions as well. Now this merge data frame has the county shape merged into the county and the hard disease data. I'm gonna be exporting this data frame into a CSV file as well. So that's one of my habits too, just keep saving CSV files, because I want to keep track of my work and I don't want to be destroying my work, so I always make copies. Now what I did was to get an access token from Mapbox, because we were going to be using their service. So I went and got an access token myself, and I pasted here into a variable called Mapbox access token, because we're going to be using this token. Now we're going to be creating this data variable, which is going to be graphing this Github Mapbox, which is a map from Mapbox that is going to be displaying the map of the United States. So I'm setting up the latitude and longitude coordinates, because those are the coordinates that we need for the space of the United States. Now I'm creating this layout variable, which is going to be a dictionary with different parameters. We're going to be using this mapbox attribute, which is going to be a dictionary containing a layers variable with another dictionary inside of it. And we're going to be setting up this as a GeoJSON for the type, and we're going to get the source link, which I'm going to be putting into the file that I'm gonna be having for you guys to download, so you guys can copy this link as well. It's from Github Repository, and we're gonna be having also these other parameters as the color, if you want to set up the color. But we're gonna be using the access token that we set up earlier as a mapbox access token variable. And after we're done defining these parameters, we're gonna be creating another variable called fig, which is going to be a dictionary containing the data and the layout variables. What I'm doing next is running this script, which is plotly.plot fig, and then the file name. I'm setting up just this name, but essentially this link is going to allow you to display the map into the browser. Next, I'm gonna create a variable called bins, which is going to obtain the match range values from the hard disease data frame, and it's gonna only obtain the unique values, and they're gonna be sorted because we're gonna be plotting these bins into the application. And we're going to convert them into a GeoJSON file. That way we can later on use it into our application. So the cell didn't run because I didn't run all of the cells before, so I rerun everything and now it's working properly. Running this cell, what it did was it created different GeoJSON files containing the ranges of the bins range. So it's going to split the counties into and assign them into their design range. That way we can later on use them into our map and color code them, so that way we can distinguish like the intensity as the value increases or decreases, the color should change. That way it's easier to identify them. So I repeated the same steps for the COVID-19 data, and I obtained the design GeoJSON files with different match ranges because they have different values, and I saved the GeoJSON files into a folder called 2020 because I have the data, the COVID-19 data from the year 2020, and I saved those files inside this folder. So I'll be putting the files and folders that you need to follow this tutorial in the repository. So they won't be exactly the same files that I have on screen, but I'll be just putting whatever you need. So don't worry that I'm having different names of the files that I'll be having on the repository, because essentially the same thing. The process won't change, but the name of the files could change. After you download the data from the repository, we can continue building our Dash application. For that, I'm going to go back to PyCharm. Okay, so now it's time to load the data. For that, we're gonna create this variable called app path, which essentially is going to just get the path of our current location. That way we can import the necessary files that we need to make this application. For that, we're gonna also create a variable called df_lat_lon, which is going to contain the CSV file of the latitude and longitude of the counties of the United States. So we're gonna create that variable, and we're gonna call the pandas.read CSV file and then our current location. Okay, so now we want to make sure that the zip codes are 5 characters. For that, we're gonna call the df_lat_lon brackets fibs, which is the column of the zip codes, and we're gonna apply a lambda function, which is going to be the string x.cfill5, which is going to make sure that it has 5 characters. So I went back to the existing latitude and longitude CSV file to delete the space that I knew was there because I saw the Excel sheet. But once I upload the file, I'm gonna make sure that it doesn't have this issue for you guys. So I'm just correcting that, but you guys don't have to do this step. Okay, so now I'm gonna load the hard disease data, and for that I'm gonna create this variable called df hard disease, and I'm going to repeat the same steps that I did for when I loaded the latitude and longitude data frame. So I'm gonna call the path and just also specify the CSV that I'm going to use. Now I'm doing the same thing that I did for the latitude and longitude data frame, which is define that the zip codes column has 5 characters, and for that I'm gonna call the same lambda function, which is cfill5, to make sure that it has 5 characters. The next thing I'm going to do is rename a column inside the hard disease data frame, which is the hard disease value. I'm going to rename it into confirmed cases. And the reason why I'm renaming it confirmed cases is because once I'm going to add the COVID-19 data, I want to use the same name to call either, whether it be the hard disease values or COVID-19 values. So I want to have a specific name for both diseases, so whenever we interchange years or diseases, it's gonna have the same name and it's gonna call the same name, and it's gonna be easier to work with like this. Now I'm going to create a variable called years, which is going to be a list of years to interchange between diseases and obtain data from different years. So for now, I'm just going to use the year 2018, which is going to be specific for the heart disease data. But once I use the COVID-19 data, I'm going to add the years for the COVID-19 data. Now what I did was I created this variable called hard bins, which is going to be the bins that will define the values in color of our choropleth map. It's going to contain different value ranges. For that, I created this list of values, and we're going to use it later on to define the colors inside the choropleth map. That way it can have a better visual understanding for the user. The next step will be to import our access token from Mapbox. For that, I'm gonna create this variable called Mapbox access token, which is going to contain my access token to use their service. Then I create this variable called Mapbox style, which is a style of how the map will look in our application. There's a variety of different styles that you can use for this map. You can search inside the Mapbox website and find whichever suits more your style and how you want your application to look. But for me, I'm going to use this style that I wrote on the screen. After all that is done, we're gonna move to the next steps, which will be to create the layout of our application. So for those that have a web development knowledge and HTML knowledge, you will find this really similar. Okay, so we're going to run this if statement saying that if underscore name underscore equals underscore main underscore, we are going to run the app server, and we will be able to debug the application because we're saying debug equals true. We're gonna start by creating the app layout by defining the header. For that, we're gonna call the HTML.div, and then just define the header. We're gonna put an H4 tag, which is gonna be the title. We're gonna call it health problems. I'm going to run the application by clicking the green button, and that way we can display what we have so far, which is just the title of health problems and the brief description. So the application is already formatted because I have a CSS file called Opinoid inside the assets folder that I'm going to also put inside the repository. That way you guys can download it and you don't have to spend time creating the CSS formatting. But you can go ahead and take a look at it, and if you want to modify, change the colors or whatever you want to do, just feel free to do so. I know some of you guys don't like this kind of dark theme, which is essentially just like a darker blue, but if you want to have like a lighter theme or whatever, just go ahead and go to the CSS file and just modify it, change the colors and whatever you want to do. And also for the map, like I said before, we're using a Mapbox style, so if you want to change that style to something of your preference, just go ahead and change it. Now I'm going to create a new div, which is going to be the app slider containing the years that will allow us to interchange between diseases by changing the year. But if you want to set different parameters or whatever you want to do, just feel free to do so. This is just an example of how you can create this slider in load data based on the different selection. As I mentioned, we're gonna be using this slider to interchange between years. For that, I'm going to specify two different ranges of years and where to start. For that, I'm going to set up the minimum and the maximum and just set it to start as the maximum year. We have to define the year values as strings, that way we can use them with the slider. We add two more years to the years list, which will be the COVID-19 years, 2020 and 2021. The next step will be the actual choropleth map, which I will name the ID heat map container. And then I'm just setting up the title of this choropleth map as adjusted mortality rates. And for that, I'm gonna format the year that we're displaying. That way we can also what year we have selected. And as I mentioned, we're using similar formatting as HTML. For that, we keep using p tags, divs. So the DCC.graph component allows us to render plotly power visualizations. Anything that says DCC means dash core components, which contains style and layout that allow us to do this interactive functionality, and we're able to also customize these styles and layouts of the components that we are using. After saving what we have done, we will be able to see the space where the choropleth map will be, along with its title that we specified to be. Okay, now this new div will be named the graph container chart selector, because this will be a drop down menu that will allow us to interchange between both diseases. So for the drop down menu, so far I'm just going to add the heart disease option, and on the attribute variable that says value, I specified to be confirmed cases, but should I put the heart disease because that's the value of the heart disease. But this is what will essentially will be giving us the option to select what kind of data we want to display into the bar chart below the choropleth map. Okay, now let's move into the callbacks. The callbacks are responsible loading the data when an action gets triggered within the app. So whenever an action is made, it's supposed to load different data according to its selection. As defined on this callback, the data will be defined based off the value of the year slider, and it will output the data into the figure, which is the choropleth map. It will be county based, that's why it's defined county choropleth. Now I'm creating a function called displayMap with the arguments of a year and figure. This will define what type of data gets displayed into the map, and it will also display all the different colors, which will be the colors of the bins based on the ranges. So you can mix and match different colors for your preference on these ranges. Okay, so inside the function, we're gonna set up this CM variable, which is color management. It's going to be a dictionary containing the hard bins and default color scale, which we will define later on, which will be the colors of the bins based on the ranges. So you can mix and match different colors for your preference on these ranges. Okay, now another variable inside this function will be data, which will be a dictionary of the latitude and longitude coordinates, which will match the coordinates of the map box. We're gonna set up this if statement, which will be based of the year selection. So if the year 2018 selected, we're going to display the data according to the year. We're going to display an annotations section, which will describe what type of values they're inside this bins range, which in this case will be heart disease values per 100,000. And we will define the color and as well as the place where these annotations will be placed. We will create another if statement that will be that if the year selection is 2018, we're gonna display the bins with its color range. So for that, we're gonna do annotations that append, and then the dictionary displaying the dictionary with the parameters specifying where the bins should be placed and the color that they will have. The following if statement will declare where the layout will be placed. So we're gonna have the map always set up to be in these coordinates, but if you play with the map, let's say you zoom in, zoom out, or just select different ranges, you don't want the map to be moving if you're not moving it. So for that, we're gonna center it, and we're gonna add this zoom feature where you can just be zooming in or out. The following variable called layout will be a dictionary specifying what mapbox style we want to use based on the style we provided before from the variable mapbox style, and as well as use the mapbox access token which we specified before. We're gonna add two different functionalities to the layout, which will be hover mode, so it can project closest to the selection you have with your mouse, and also drag mode, which will be lasso. The lasso gives you freedom to select whichever space you want to select with the lasso. Okay, now we're gonna get the counties geometric shapes. We're gonna create this if statement specifying the year to be 2018, and then inside this if statement we're going to create this variable called base URL, which will contain the link to the repository where we have the folders of the GeoJSON files. So I'm copying the URL of my Github repository, and at the end I'm just putting a /master. Inside this if statement we're also going to create a for loop, which is going to be for bin in hard bins. It's gonna have a variable called geoledger, which is going to be a dictionary specifying that the source is going to have the base URL that we specified plus the year, and then / plus bin plus GeoJSON. This is how it's going to know from which source it's going to acquire the data. So I saved and run the app, but as you guys can see, it's not running, and that's because I had typos on the words county, choropleth. So I just looked for those words and I fixed my typos, and now it's working properly. I had also typos on the words latitude and longitude, so I just corrected those typos. Okay, so I forgot to specify to return the figure that we want to return. For that, I create this variable called fig, which is a dictionary containing the data and the layout. So just returning the variable fig, which is a figure, and that's what is going to project the map into the space that we designated for the choropleth map to be displayed. The map is displaying, but as we see, we have the words heart disease values per 100,000 not in the right spot. So for that, we can move the X and Y coordinates to specify where we want to display the text. So now if we want to display the data that we selected from the map, we're going to create this callback, which is going to output the selected data from the figure. The inputs will be the selected data from the county choropleth, the value from the chart dropdown, and the value from the year slider. Those will be the parameters that will determine what kind of data we want to output. In order for the callback to work, we have to create this function called display selected data, which will have the selected data, sharp dropdown, and the year arguments. Inside this function, we're going to have this if statement saying that if there's no selected data, we're going to return this dictionary of the data of the hard disease counties and the hard disease value. This is what will allow us to display that overview that I showed before. We're going to have a title inside this visualization, which will say click drag on the map to select counties. So giving instructions to the user to click and drag into the map, into the visualization, if they want to select individual counties, so they can have a better overview of the values of the bar chart. So now if there's data selected, we want to know what data is selected. For that, we're creating this variable called PTS, which is going to be the points or the area that is selected, the FIPS, which is the zip codes that were selected. Now for loop saying that if the county selected only contain 4 characters for the zip codes, it will add an additional character so it can have 5 characters. Now I will create this variable called df1, which means this is going to be the first data frame that will contain the heart disease data. So I'm specifying that this variable is gonna subset the heart disease county code, which are the zip codes again, to be on the point selected, which will be the FIPS variable. So now it's time to display the values inside the chart. So for that, we're going to create this if statement saying that if the hard disease value in the chart dropdown is selected, we're going to display the hard disease data. The df1 should be match the year selection, so it's going to subset and specify to be the year selected. The title that we will give to this bar chart will be heart disease. It will aggregate based on the heart disease value. So now it's time to display the values. So for that, we're going to create this if statement saying that if the heart disease value in the chart dropdown is selected, we're going to display the heart disease data. Okay, so I paused for a second and realized that the map is not displaying the county shape color bins, and that's because under the if statement that it's supposed to get the county shape and match it with the hard bins color, I accidentally included a comma after the for loop. So now that I delete the comma, it's displaying the county shape with its designated color range bin. In order to display the selected data from the choropleth map, we're going to create this if statement saying that if the hard disease value from the chart drop-down menu is selected, we're going to plot the data that we selected on the map For that, we're going to use this iplot function, and we're going to define the values to be the x-axis to be the year, the y-axis to be the confirmed cases, which are the heart disease values. And we're going to color code them and just categorize everything by counties. This for loop will give us a grid view in our selected data in the bar chart. And now if we select data in the choropleth map, we should be able to display the data in the bar chart. The application is working properly for the heart disease data in the year 2018, but since we don't have the data for the COVID-19 yet, there's nothing to show. So if we select the following years, we don't have anything to output, so the application gives us these warnings that it's not working. To obtain the COVID-19 data, we're going to get it from this Github Repository that is posting daily updates of COVID-19 data from the Center for Systems Science and Engineering at the Johns Hopkins University. In order to keep getting the daily updates, we're going to have to make a dynamic URL, and for that we're going to create this variable called today that is going to obtain the current date. That way the URL links to the most current update because it is specifying from what day it's getting the data, which is going to be the current day. Going back to the imports, I deleted a few imports that we are not going to use for this tutorial. I had them there because those were necessary for me to deploy the application, but I now deleted them and I'm going to import date from datetime and time delta from datetime to get the current date and also make it into the format that we need to match the format that the date is displayed on the URL from the CSV for the GitHub repository. We're going to put it as date.today, which gets the current date, but we're gonna make it into a string and we're gonna format it as month first, day, and then year afterwards. Between them, they're gonna have a dash. That way it matches the URL from the GitHub repository. Now we have to create this variable called COVID URL, which will be an F string where we will put the URL from the GitHub repository that contains the COVID-19 data and it's updating daily. Because we're going to be using this URL and we have the today variable, the URL contains a date inside the URL to distinguish from which day we are getting the data from, because each URL contains the data, contains its CSV file that also has a date on it. We're going to also apply the Lambda function to the zip codes, which is the FIPS column from the COVID-19 data frame. So we're going to apply the same Lambda function that we apply for the heart disease county code column. So we can just copy the same function and apply that way the zip codes have 5 characters. going to rename a few columns, which are going to be admin 2. I'm going to name it county. Confirm, I'm going to rename it as confirmed cases to match the heart disease column values. For the COVID data, we're going to add a column that will be the year column. In this case, I will put the year 2021 because this is the current year. But if you want to also add the year 2020, you will have to match the data with the year. Do something similar to the match ranges function that we did. But for this example, I will just put it as 2021. And I'm going to specify it to be integer. I know I wrote it as an integer, but I just want to make sure that it's really specified to be an integer. Since I was having issues with the deployment, and I just specified to be an integer, and that's how it works with Heroku. I created the range bin values for the heart disease, and also I will create the COVID bins values. There will be different ranges for the COVID, and I will also have a different color for COVID. That way we can distinguish both diseases. For heart disease, I will leave it as a greenish type of color, and for COVID, I will make it into a variety of red colors. We are going to add the section on the drop-down menu to select the COVID-19 data so it can be displayed on the bar chart. So for that, I'm creating an other options section that will be labeled as COVID-19, and the value will be COVID-19. In the display map function, we are going to add another variable called cmCovid, which is color map COVID, that will contain the bins and the color scheme of the COVID-19 data that we specify as red color scale. So we will be copying most of our previous if statements and then just converting them into the year 2021 and defining the variables to be for the data of the COVID-19 data, and that's how we're gonna work it. It's pretty much repeating the same steps, but I'll be showing you guys how this is done. Under the selected data section, we are going to define a df2 to be the COVID-19 data, and we're going to specify that the zip codes from the data match the zip codes from the map. Okay, so we're going to have to make some modifications to the COVID data for us to be able to display the data into the choropleth map and the bar chart. I paused the video and realized that I deleted cufflinks, so I'm sorry for that. Let's just add it back, because this is a library that connects pandas data frames to Plotly and enables us to create the visualizations directly from pandas. One modification that we have to do is that on the county column, we have to map the string of the county, add a comma, and then also add the county again as a string. And we have to add this modification in order to plot the data. I just found it easier to add the word county again next to its county, so like having a multiple instead of deleting it, because I'm not sure how many values are in each county, so the data was plotted like that, so we have to just continue how it's being used. So we have to use the county name twice. Okay, so we're gonna create this function called remove last to num, and this function, what it will do is remove the last two string characters of a word in a column. We're going to add the column year and set it up to the year 2021. Set it up as an integer again in order for the application to work, because when I didn't set it up as an integer it didn't work, so we have to set it up as an integer. So on the county code column, which is the zip codes, we have to remove the last two characters of the zip codes, because on the data of the COVID-19 they have two extra characters that we don't need, and they will create a disturbance once displaying the data, because it's not gonna match the zip codes to the zip codes of the COVID-19 data. So we're gonna use the function that we previously defined, remove last to num, that is going to remove the last two characters that are unnecessary. On the county code column, we're also going to replace this value of 00n. We're just going to replace it to make it into a 0. And at the end, we're going to apply the same lambda function to ensure that the zip codes are 5 characters. I ran the application, but I was expecting an argument on the remove last two function, so I just removed the parentheses. And now the app is not working, because on the remove last two num function, I added the -2 as a string by accident. It was just supposed to be a column -2, that way it's going to remove just the last two characters. Now the application ran, but the layout is not working properly, so I will have to debug it and see what's going on. Okay, so first mistake that I found is that I had the if statement set up as the year 2020, but we're just going to use the year 2021, so I just change it. On the if statement that acquires geometric shapes from the Github repository, I had this if statement saying that if the year 2018 or 2021 is selected, we will acquire the geometric shapes. But I wasn't supposed to do it this way, because it is going to display the bins on the map, so it's not possible to display two different type of bins with just one if statement like this, because the hard disease and the COVID-19 have different type of bins. So I'll have to divide this if statement into two different categories, one for heart disease and the other one for COVID-19. And also I realized that the color should be matching the COVID-19 bins color, so I had it as a CM, which is the heart disease, so I have to change it to the COVID-19. After a bit of debugging and scrolling, I found that nothing was getting returned after the if statements to acquire the geometric shapes of the map. So what we have to do is create a return statement to return the fig, and for that we're going to create this variable called fig, and then make it into a dictionary declaring that the data is gonna equal the data, the layout will equal the layout, and we will return the fig afterwards. Now the choropleth map is displaying, and if we select data for the heart disease, we are able to display it onto the bar chart, so it's working properly. So the heart disease data is working. But if we change it to the COVID-19, we can see that it's giving us an error in one of the beans value, and that was because on the if statement for the COVID-19 to acquire the geometric shapes, I had the for loop stated as for binning hard beans instead of COVID beans. So it was trying to match the hard disease beans to the COVID beans, which was not matching, so it was throwing us that error. But now that I changed it to COVID beans, it should work. And now as we can see, the choropleth map is displaying the COVID-19 data in red because we set it up to be a different color, and if we drag into the map it will display the county data for COVID-19. And if we switch it to the heart disease, it should display the data for heart disease. So now the application is completed and we're able to interchange between both diseases by using the slider and the drop down menu. So this was just an example of how you can display data into this choropleth map and bar chart using Dash. So this should give you an idea of how you can create a similar application to this one, and how you can plot your data and how you can end up with a similar result. I hope this walkthrough of how I created this Dash application was useful and you were able to learn something new. And feel free to refer to the Github Repository where I have all the files and the code for this application. It was quite a long tutorial or walkthrough, but I just wanted to concise it into just one video. That way you don't have to go back and forth between videos. I don't want to take up more of your time, so with that said, thank you so much for your time. Please like and subscribe if you find it useful or entertaining, and thank you so much.